Fractals are one of my all-time favorite concepts in mathematics. Like the human face, fractals contain symmetry, but in a rather different way. Fractals consist of geometric designs that can be subdivided into parts, each part a smaller copy of the whole. You can zoom in or out of the design, but you will see the same image repeated at all sizes. It's a bit tricky to explain in words, so let's look at some images. Fractals aren't found only in the math classroom. They're everywhere in nature. This fern is a fractal because each branch is similar, same shape, different size, to the whole. This flower is a fractal. And so is Romanesco broccoli. The Koch snowflake is a classic example of a fractal. The design is made by starting with an equilateral triangle. This is called the first iteration. Iteration means repeating something again and again. Fractals have iterations of geometric designs, the same shape repeated at different sizes. In geometry, this is called similarity. Same shape, different size. In the second iteration, 3 additional, smaller triangles are added to each of the 3 sides. In the third iteration, more equilateral triangles are added to every surface. Notice how the number of sides on the shape increases exponentially. We can zoom in on one side of the Koch snowflake, but the zoomed-in image looks identical to the original. This is the definition of self-similarity. One reason I like fractals is that they force us to grapple with the idea of infinity. For example, I'm sure that you remember learning how to find the perimeter of an object from grade school. What is the perimeter of the Koch snowflake? In theory, the Koch snowflake never ends. No matter how far we zoom in or out, we will see the same image forever. In other words, if an infinite mathematician were to draw this fractal, he would have to add smaller and smaller triangles onto his design. He would have to keep zooming in on the image in order to draw the tiny triangles for the next iteration. His work would never end. So what is the perimeter of Koch's snowflake? Infinity. Now that you have some background on fractals, I'm going to teach you to create a fractal of your own. The name of this design is the Sierpinski triangle. Like the Koch snowflake, start by drawing an equilateral triangle. Remember that equilateral triangles have sides and angles of equal measure. Next, divide your triangle into 4 more equilateral triangles. You will have to find the midpoints of each of the 3 line segments in your original triangle, then connect them. Now repeat the same process inside the outer 3 of the 4 newly created triangles. You can keep adding triangles either until you reach infinity or until you get bored. What patterns emerge as you add iterations to your triangle? How does the number of triangles change with each iteration? By drawing Kaspersky's triangle, you're making a design that's not only beautiful, but mathematically and philosophically complex. In the coming days, contemplate the mystery of infinity, as well as the exciting prospect that the infinite regularly permeates your everyday life.